Hello and welcome to our three-part webinar series on ArcGIS Pro for Intelligence. This is part 3 of the series entitled Link Analysis with ArcGIS Pro Intel. My name is Carl Walter. I'm the Director of Home and Security Solutions at Esri. I'll be facilitating today's session. Also participating with me in this webinar are the following folks from Esri. We have James Jones, one of our product engineers, Natalie Fairstein, a product lead for intelligence, and from the government side, joining us, we have Paul Ebel. Commander Ebel is over investigations at the Green Bay Police Department. In addition to managing investigations, he also leads many of the security efforts at some of their large special events in Green Bay, most notably those involving the Green Bay Packers, but also non-football events at Lambeau Field like concerts and pro soccer games. Our agenda today is real simple. We'll start off with the core component of today's webinar, which will be a series of technical vignettes on the link analysis capabilities found in ProIntel. For background purposes, we'll begin with how we define link analysis, including a little history on the topic. We'll walk through a step-by-step review of how to create a basic link chart and show how to combine a map and link chart, including the dynamic link between the two. We will demonstrate and visualize movement analysis tools and link charts together, leveraging GPS data that will allow us to connect and chart people and link them with meeting places. Then we'll define and demonstrate some of the different types of analysis capabilities commonly used in network and link analysis to include centrality, clustering, neighborhood, and path. These tech demos should really reveal the true differentiator when combining GIS and link analysis, and that is the ability to first visualize, analyze, and connect relationships, but also the ability to infer relationships around time and space. Following the tech demos, Natalie, James, and I will host a short roundtable discussion with Commander Ebel. We'll ask him to share some of his thoughts around GIS and link analysis and some tactics that he might deploy into the future. And after the roundtable, we'll spend 5 or so minutes of Q&A, depending on the amount of questions you folks submit during the webinar and how much time we have available. And after the Q&A will close out, you'll be directed to an online survey that we hope you'll take the time to complete. And that is our agenda for today. Let's get started with our tech demos, and I'll turn things over now to Natalie and to James.
Welcome to the third webinar in our series, Link Analysis with ArcGIS Pro Intelligence. My name is Natalie Fairstein, and I'm here with James Jones, one of the talented product engineers on my team. James and I both started our careers as intel analysts in the military. I was a soldier, and James was a Marine. We've used these link analysis techniques while supporting operations, so we're excited to be here today to show you how you can leverage relational, spatial, and temporal analysis in ArcGIS Pro Intelligence. Link analysis, also known as network analysis, is a technique used to evaluate the relationships between several types of entities, such as organizations, individuals, objects, or activities. For eons, link charts have been used by analysts and investigators, even without the aid of a computer, using sticky notes and markers or thumbtacks and string, photos and maps to manually perform link analysis. Of course, the manual way does have its limitations. So visualization tools like the link chart in ArcGIS Pro Intelligence help augment this technique by organizing and displaying data, assisting in identifying associations within complex networks, and performing algorithmic calculations on the graph. Analysts may use link analysis to identify key nodes and hubs within social, organizational, and infrastructure networks, and find their associations to various groups or activities. Link analysis can clarify what is known and what may be missing about the network being analyzed. Link analysis programs are standard components in most intelligent systems. However, link analysis in ArcGIS Pro Intelligence differs in that not only can you visualize and analyze the relationships in connected data, but you can infer relationships based on spatial and temporal proximity, providing a more holistic understanding of the current situation and what may happen next. So before we get into the steps to conduct link analysis in ArcGIS Pro Intelligence, I want to cover a few key concepts. The visualization of the network is called a link chart. In the link chart, the nodes are the visual representation of the entity. And an entity can be a person, group, activity, or other object such as a vehicle or a cell phone. The lines or links between the nodes are called the relationships. And a collection of similar entities from the same data source is called an entity type, while a collection of relationships between entities is called a relationship type. Don't worry, these descriptions will become clearer as we go along. For example, there are two entity types in this link chart. One with events, the bombings, robberies, and fraud with red labels, and one with nefarious actors, criminals and gangs with black labels. Those entities can be linked together by relationship types. In this example, the confirmed relationships are shown with a solid line, while the inferred relationships are dashed. Now, the ratio of actual relationships to the maximum number of possible relationships determines the overall density of the graph. This is a relatively sparse graph, while this graph is denser. Now, there are a number of ways to visually explore your link chart. You can filter links to remove the dinglers, those without a relationship, or those with a minimum number of links that don't meet your threshold. You can change the layouts with the click of a button to better visualize your network. Organizations are often best viewed as hierarchies, while social networks look best in an organic layout. And the results of analysis, such as suspected meeting places between unique devices, work really well in a clustered layout. And when your entities have a known location, you can view their relationship as lines on the map, helping you get a better feel for the spatial dispersion or clustering of entities. Now that you have a better idea of the key concepts, I'm going to hand it over to James, who will walk you through the steps to create a link chart in ArcGIS Pro Intelligence.
Hey, thanks, Natalie. So what I'm going to show now is just the different ways that you can go through and create link charts and create the entity types and the relationship types and everything else that is necessary to begin your link analysis project. So what we have here is just some notional data for a simulated crime family in and around Monterey, California. Essentially what I did is I went to the FBI, I looked at how the mob is structured, kind of based the data off that. But this is simulated data for that. But hopefully it'll help illustrate the point quite nicely. So whenever you go through and you want to create a new link chart, what you want to do is you want to go on ArcGIS Pro Intel and go to the Analysis tab and open up the new link chart. And with this kind of first example, I'm going to really kind of show you more of a basic type of a link chart. Just everything kind of coming from one layer, nothing overly complex, and we'll build from there. So the first thing we need to do is we need to add an entity type. We have one of two ways that we can do that. We can either click this button here, or we can click the entity type button up in the ribbon up here. So the first thing we want to do is we want to select and choose our layer that we want to create this from. So in this case, it's going to be the Monterey Crime Family Locations. And then we want to select what field that we want to create these entities from. So in this case, we're going to be creating it from the member. And then we're going to go ahead and give this a name for the entity type itself. So we're going to call this family members. Okay, I'm just going to go ahead and hit OK. And what this is going to do is it's going to go ahead and add in all of the unique individuals that came from that feature layer. So while we're here, let's go ahead and enable layers so we can, or enable labels, so we can go ahead and see who these individuals are. So in order to enable labels on our link chart, what we want to do is we want to select our family members, our entities that we just created, and we want to go ahead and turn on labels. Then what we want to do is change our color. We can change it to whatever we want. And then we also have the option of changing what field it's coming from. In this case, it just defaults to whatever field or fields was used to create the entity itself. Or we could select a different field if we wanted to, but I'll leave that as default. Now that we have all of our entities in there, let's go ahead and create a relationship type. So we can go ahead and see how these family members are related to each other. So in order to do that, we go up here and we select the relationship type button, and this brings up this dialog, and we have options as far as what we can enter here. So we can choose our source entities. In this case, it's going to be our family members entity. And then we're also going to select this, and this is going to be an entity that is related to itself. So that means that our target is going to be the same entity. And this one, we're just going to go ahead and call this works for. Now, here is where we have a few different options of creating different types of relationships. In this case, I'm going to go with the entities option, which allows us to pretty much just choose something if it's all coming from the same table. We don't need to reference any other third tables to develop these relationships or anything else like that. One option that you do also have is the ability to create a none option or a none key type, which allows you to manually draw the links and the relationships yourself. So like I said, I'm going to go ahead and select the entities, and this allows us to specify the fields that are present in our existing layer to build these relationships from. So I'm going to go ahead and select the layer that's going to be used for the source. In this case, it's the member. So this is the field that we actually built the relationship class from. And then I'm going to go ahead and select the relationship field for the target. In this case, I'm going to select the boss because that is present in the data itself. So we can do that, and we can go ahead, and once we have all this filled out, we can go ahead and hit OK, and it'll go ahead and create the relationships, and it'll draw, and it'll go ahead and default out into a layout. So speaking of layouts, we have a few different types of layouts. So we have everything from hierarchic, which gives us more of a diagram that looks similar to how like a hierarchy will be viewed. We have clustered and we have organic. So what we're looking at right now is more of an organic layout. What we're looking at now is more of a clustered layout. Clustered is very circular, and it kind of allows for edges to kind of be built on top of itself. But since we know this is a crime family and we know that the mafia is very structured, we're going to actually switch this, and we're going to put this into a hierarchic layout, and we're going to do top to bottom. We have a few different options as well. We can also do left to right or right to left. These actually work really good for like processes or anything else that you're trying to map, or maybe networks, like computer networks or any type of other logical network. But like I said, I'm going to go ahead and switch it back to top to bottom, and then we can kind of zoom in here and take a look at our link chart. So you can kind of see inside of our link chart that we have plenty of relationships. Everyone is all the relationships drew correctly, and I'm quite happy with the way that this turned out. So let's go ahead and take a look at a few other things. So whenever we zoom out here, one thing that I have noticed is we have what are known as consiglières, and that's this group of people out here who are kind of associated with the family but are not really members of the family. But if you notice that they're not connected to anybody or anything inside of the chart. So what we could do is we can make use of this filter links option up here that will allow us to set and specify a minimum number of links or relationships that a individual node must have before it gets drawn on the link chart itself. So in this case, it's default turned off. And whenever we turn it on, it's still defaulted to 0. So everything is going to be drawn and shown no matter what. Now, if we wanted to remove these consiglières down here in the bottom left-hand portion of our link chart, what we could do is we could specify a minimum number of links to 1. And notice how they went away. So again, if you didn't see that, we have all entities and nodes being drawn. But what we can do is we can just bump it up to 1, and now everything that is not connected to any other node inside of the link chart is hidden. So that's really handy. So another thing that I think is really, really interesting is the fact that with these link charts, they are directly connected to the map itself. So this link chart is built off of data that comes from this map and is tied to this layer. So one of the interesting things that we can do with that is we can do things like we can select items on our link chart and we can find out where they are existing in geographic space. So we can select this and then we can see that they're highlighted on the map. And then one of the other things that we could do is, so say we have our group connected, we can go ahead and expand this out connected, or expand out this connection by using the select connected button that exists up here in the tab, or we can right click and just hit select connected, and it's going to expand out our connections to include anything that is connected to our current node, or nodes in this case. So for instance, if we were to go select the boss over here, we can see where he is currently at on the map, and then we can go ahead and hit select connected, and it's going to show all of his direct underbosses that report directly to him. Some other things that we can do while in this kind of view is we can do something called draw links on map. And essentially what this does is this allows for the relationships that are present inside of our link chart to be displayed and visualized on the map, so you can see the connections that are created inside of our link chart, and we can display those as actual graphics on the map itself. Another thing that is interesting, since all these are tied specifically to the individual features themselves, we can go ahead and select the attributes, and we can get all the source information on a specific node. So for instance, if we select Brian Hamilton, we get all the information from him. We can get, his name, his boss, his role, and then his location as it currently stands. And with that, that is how we can go through and build essentially a simple link chart. Now, let's say that we have something a little bit more complex that we want to go through and physically look at the relationships on how it's built. So let me go ahead and close this link chart, and I'll switch to a different map that has some different data inside of it. So what we have here is we have some GPS tracks that were collected for a variety of purposes, but we're going to go ahead and analyze this. And what we want to do is we want to figure out inside of this set of GPS tracks who is moving together in space and time with who, how are they related, did they meet at all, and did any of them kind of interact with any of these known areas of interest. And then we want to visualize that inside of our link chart so we can visualize those connections that we are able to determine via geoprocessing. And this is all coming from the movement toolset that is available inside of ArcGIS Pro Intel. It's one of our geoprocessing tools that we create and maintain and make available through the application itself. So let's go ahead and create a new link chart for this data. So we're going to go ahead and go back to analysis. We're going to go to create new link chart. And then we're going to go ahead and create and add our first entity type. Now, since this is all derived from the GPS data, we're going to go ahead and create the entity type from that source GPS data. And with this, what we're going to do is we're going to select the name field, and then we're going to go ahead and call this, let's just go ahead and call this movers. And it's going to go through, it's going to iterate through all that, get all the unique IDs for that, and then it's going to create the link or the entities themselves. So let's go ahead and create some other additional entity types that we might have. So one of those is going to be these NEIs that are visible in the purple areas here. So let's go ahead and create that entity type. And we're going to go ahead and select NEIs. I'm going to call this name. And we're just going to call this one NEIs. And then the final one that we have is all the meeting areas that were identified via the geoprocessing run. So let's go ahead and create one last additional entity type, and we're going to make this derived from the meeting areas. And we're going to select the meeting area ID as the name, and we're going to call this one meeting area. Let that added in. Okay, now we're going to go through and we're going to go ahead and enable labels on this so we can see it all. Yet again, whenever we're creating the labels, we just want to make sure that we have the entity type that we want to label selected down here. Go up here, turn on the label button. You can change the field that the name is coming from, and then you have the option of changing, the color, the font. So for instance, if we wanted to go something a little bit more fancy with this one, we could. And then, change the font size as well. So, all right. So now that we've gone ahead and created our nodes, which are derived from our entity types over here, let's go ahead and start creating our relationship types. So the first relationship type that we want to actually do is we want to go through and answer that question: who inside of this group was moving together inside of space and time? So in order to do that, we're going to go ahead and create a new relationship type. And then for this one, we're going to select movers as our source, and our target is going to be movers. And we're going to call this one co-traveling. Okay, for this one, we're going to use something slightly different. We're going to use the foreign key type. Now this allows us to specify a separate table that defines the relationships between our source nodes. So in this case, we're going to go ahead and select the layer that we want to use to define those relationships. In this case, it's going to be the summary table. Then we're going to go ahead and select the key field. In this case, it's going to be name. And then we're going to go ahead and select the target key field, and yet again, it's going to remain name. So we're going to have the matching source key field from the foreign key layer, and essentially what this does is this is the field that exists inside of this separate table that defines the relationships. So I'll show you kind of what that looks like inside of here. So we have a few different fields that we could use, but in this case, we're going to start with traveler ID. The next thing that we're going to do is we're going to select the target key field, very much the same, but this time we're going to select the co-traveler ID. We're going to go ahead and hit OK, and it's going to go through and it's going to build those relationships. As you can see, it built some additional relationships. So now what we have is we have identified who was traveling together with who inside of this specific data set. Now, we can find additional insight and we can identify who actually met with who. So in order to do that, we're going to use this meeting details, which defines individual meetings that have occurred between members who were moving up here. So we have two fields inside of here, participant 1 and participant 2. So what we're going to do is we're going to build another relationship type, and it's going to be movers and movers, and we're going to call this relationship type met with. Yet again, the key field is going to be foreign. And then we're going to select the meeting details layer. Now, for the source entity key field, yet again, it's going to be name. Same for the target entity key field is name. Now, for our matching source key field, we're going to select participant 1, and then in the target key field, we're going to select participant 2. And then we're going to go ahead and hit OK. Let that build its layers. Okay, so now we have additional links that were drawn showing the meetings that were observed inside of this data that was derived via geoprocessing. So now what we want to start doing is we want to start tying these individuals to the meeting areas themselves and then also to these NAIs. So let's start with tying these individuals to the NAIs. And we're going to do that through this compare areas result. Compare areas results are fairly simple. All we have is the area ID, which corresponds to these purple areas. And then we have the track ID, which corresponds to these individual movers. So in order to create this relationship, we're going to go ahead and create another relationship type. We're going to choose our source entity, which is going to be, let's keep that one as movers. And then for the target entity, we're going to choose NAIs. And then this one, we're going to call located in. And then choose for the key type, we're going to go ahead and select foreign. The layer is going to be the compare areas result. And the source entity key field is going to be name. The target entity key field is going to be name. And then the matching source key is going to be the track ID. The target entity key field is going to be the area ID. We're going to go ahead and hit OK. As you can see, it built some relationships between these individuals and some of these specific areas of interest that we were interested in. Now, finally, we want to tie these individuals to the specific meeting areas that they met in. So previously, we identified who met with who, but we want to tie those specifically to locations on the ground. So let's go ahead and create another relationship type. This time, we're going to build one from movers to meeting areas. And then we're going to call this met in. Key type is going to be foreign. And the layer is going to be, yet again, the meeting details. And the key field is going to be name. And the key field for this one is going to be meeting area ID. Now what we're going to do is select participant 1 and then meeting area ID for the target. And we're going to go ahead and build that. Let that build. And there we go. So now what we can see is we have all of our relationships built. We can go ahead and change this layout to give us a better representation. So let's go ahead and select organic, see what that looks like. There we go. That one looks pretty good, and we can actually see all the different ways that all this data is tied together. So what we've done is we've started off with a simple GPS track and some NAIs, and using some geoprocessing tools, we were able to identify who inside of this GPS data set was moving together in space and time. We were able to identify who was meeting with who, and then who was located inside of the specific areas of interest that we were interested in. And then we were able to take the results of that geoprocessing and visualize it inside of a link chart and be able to kind of understand more fully how these individual tracks are related to each other and how they're related to the NAIs. Thanks.
Thanks, James. Now you may have data that looks exactly like what James showed, or it may look completely different, and that's okay. There are several supported data storage patterns that we're going to cover. One pattern is when entities are derived from a single field. An example of this is a list of names. In this case, James, Natalie, Tony, Eric, and Matt are all unique entities. Sometimes entities are derived from multiple fields. In this example, we have outgoing and incoming phone numbers that could make up a phone number entity type. There are times when entities and relationships are in the same table. So here we have entities, the students and teachers, and the key that defines the relationship, which is the class ID, and they're all stored within the same table. Entities and relationships can also be stored in different tables. Here, the table on the left has the master phone list, which is the entities, and the table on the right has a list of phone calls, which link the phone numbers together. The primary key for the phone calls is the call ID, while the phone numbers are the foreign keys. Lastly, you may gather information about connections from a number of different sources, such as reporting, biometrics, or forensics, and sometimes that information isn't cleanly stored in a table. In this case, you can manually draw links between your entities. So before James shows a demonstration of conducting link analysis in ArcGIS Pro Intelligence, I wanted to quickly introduce the methods that we support. These methods fall into 4 buckets: centrality, clustering, neighborhood, and path. Centrality helps you identify the most critical or influential entities in a network. Centrality is often used to analyze social networks. Betweenness shows how often a node lies on the shortest path between each pair of nodes. So it works well for measuring which nodes represent the connective tissue, if you will, between different components on the link chart. Closeness is good for identifying which nodes are critical for information, influence, or even spreading disease. Those nodes with a higher closeness score have the shortest average distance to each other in the link chart. And by distance, we mean hops between the nodes, not physical distance. Nodes with a high degree give a count of how many immediate connections a node has. It shows you who is literally most connected in the network. Eigenvector is interesting as it hypothesizes that important nodes tend to be connected to other important nodes. Eigenvector does not account for directionality, so it assumes influence flows in and flows out, while PageRank does account for directionality. Looking for communities in a network through clustering is a really good strategy for reducing complexity and extracting functional components. Clusters can be defined as a group of nodes that are more connected within themselves than with the rest of the network. Biconnected components are clusters where each node is connected to more than one node, so that if you removed a single node, the component is still connected. Edge betweenness uses the links, edge being another term for a link or relationship, to measure the connectedness of components. The method runs through the network, removing each link at a time and returning the highest quality clusters. Hierarchical clustering uses a bottom-up approach in which each node starts out as its own cluster, and pairs of clusters are identified as the method moves up the hierarchy. And lastly, k-means partitions the network into clusters by minimizing the distance, or the number of hops, from the centroid of identified clusters. In link analysis, a neighborhood is defined as nodes connected to a source node with up to 3 degrees of separation. Neighborhood analysis can be computed for incoming, outgoing, or both directions. And comparing neighborhoods allows you to see which nodes have shared neighbors. Path analysis, as you may have assumed, finds the paths between nodes. All paths indicate every possible route between source and target nodes, while shortest path finds the least degrees of separation between the source and the target. Now, I realize that was a ton of info and I said it really quickly. So if you'd like more details, I'd encourage you to hit up the ArcGIS Pro Intelligence documentation or just reach out. We'd be happy to share resources with more details, including the names of the mathematicians that developed these algorithms. So with that, I'm going to hand it over to James, who's going to show you link analysis in action. James?
All right, thanks. So now we want to talk a little bit about some of the analysis options that you have inside of the link chart itself. So for this, I'm going to start again back with our Monterey crime family link chart. And if you want to access some of the link analysis capabilities that are present within Pro Intel, one of the things you can do is you can go up here to the link analysis button, go ahead and select that. And what this does is this brings up this interactive link analysis window that we have. And we have quite a few different methods that Natalie previously went over. So for instance, one of the first things that I always like to do is I always like to start off with just kind of understanding the link chart and just kind of understanding who the major players are inside of this link chart. And the best way to do that is to start off with something called centrality analysis. Now from here we have quite a few different options that we can select with. So I always like to start off with and understand who is the most connected individual inside of my link chart. And the best and the most easiest way to do that is to use something called degree centrality. Now, degree centrality is, like Natalie went over, is essentially just the raw number of connections that an individual has. In this case, our most connected person is Pete Fisher, who sits atop of our link chart, who is essentially the boss of our crime family. Now, this makes sense. He has a lot of people directly working for him. You know, he's kind of a big deal inside of this link chart. Now, we have other options as far as centrality that we can measure. We can measure outgoing centrality. In this case, yet again, Pete Fisher is still number one with 19, but if you notice, some of those other ones kind of dropped as well. But we can also select incoming. And this, since we have a hierarchic, more of kind of a tree, no one's really going to be dominant. I'll show you what this looks like again inside the Adelaide link chart as well here in a minute. Some other things that are of interest would be, you know, who is the most likely to contain a piece of information, as in how does the information flow inside of this network and how can we best understand that? We can use something called betweenness centrality. Yet again, Pete Fisher right up there at the top, but we also have Peter Montgomery, who is also fairly high up there as well. So if you noticed, I don't know if you noticed it on the degree centrality, but whenever we select something inside this table here, what it does is it goes ahead and it also highlights it on the link chart itself. We can also go ahead and say if we wanted to find out where Eric Wood was, we can go ahead and right click on him and hit zoom to, and we can do that again. Say we wanted to find out where Joshua Smith is, we can go ahead and select and zoom to Joshua Smith, etc. And we can zoom back out to the link chart. Now, let's go ahead and take a look at some of our other analysis methods that we have. So for instance, let's go ahead and take a look at some of the clustering methods that we have. So in this case, Natalie already kind of went over some of these, but let's go ahead and take a look at what they actually look like. So let's go ahead and find, say, who are the clusters that exist inside of here according to edge betweenness. So as you can kind of see, kind of broke it out. Now let's go ahead and see what cluster 9 might contain. So if you notice, it actually does a really good job of picking up these little cells that are present inside of our data. And as you can see, it kind of keeps on moving around. So let's go ahead and zoom to this little cell, see who's there. And there we go. We have Joshua Smith and his little crew. Same for this one. Now, some other things that we could possibly do is we could take a look at the neighborhoods of any given individual. So in this, we have a few different options. We can either just look at the neighborhood of a specific individual. In this case, say I wanted to find the neighborhood of Peter Montgomery. All right, cool. So we find Peter Montgomery, and we can see all the people who are directly connected to him. Now, say we wanted to expand this out. So we now have one hop out from Peter Montgomery. And what this does is this gives us our list of everyone who is one hop out from Peter Montgomery. Now, let's go ahead and expand this out. We want to say, show me everyone who's 2 hops out from Peter Montgomery. Notice how the link expands out. And we see a lot more people connected to him. Now, say that we were interested in copying this information. What we could do is we could go up here to the copy results. And what this does is this puts us into our clipboard. So we can go ahead and say we want to open up Notepad. We can go ahead and paste that in there, and it gives us our full results of everything that we were interested in as far as everyone who's 2 hops out from Peter Montgomery. We also have the option of clearing those results. Now, say we wanted to compare the neighborhoods of 2 individuals. So yet again, we can find that underneath our neighborhood, and then it's just compare neighborhoods. So in this case, we're going to select 2 different nodes. We're going to select our source. Let's say we want to select Kevin Wallace. And then we also want to select James Johnson. So right now they only have one common neighbor, and that's Peter Montgomery. Yet again, makes sense whenever you're looking at a hierarchical structure like this, but yet again, it's really useful for identifying who those common neighbors might be. And then finally, the last thing we want to talk about is understanding how people are connected and understanding the paths between those. So say that we wanted to find out how Peter Fisher and Tyler Fields were connected and what's the shortest path between those two. We can go to our paths and we can go to our shortest path. And then what we can do is we can select Tyler Fields as our source, and we can select Peter Fisher as our target, and we get a path back. And then what we can do is we can select that. And if you notice, it selects every node in that path, and the intermediate nodes are actually colored in blue while the source is in green and the target is in red. And again, we can also go ahead and copy that to our clipboard if we wanted to. And we can paste those results to any other document that we would want to keep there. So that's some of the analysis workflows that you can conduct inside of ArcGIS Pro Intelligence now. So with that, there's a lot that you can do to kind of really expand this out. There's different ways that you can look at different clusters and everything else, and it really kind of depends on different types of data. So let's take a quick look at how some of this might look inside of the Adelaide link chart real quick. So one of the things that I wanted to show you is kind of how something like degree centrality can change on something that is not a hierarchic kind of structure like what we had before. So here we have a degree centrality with all directions. We have team 2 is the most connected node inside of here. Now let's say I want to figure out which one has the most outgoing connections. Yet again, still remains team 2, but we can kind of see everything else changes underneath. And what this actually does is this represents kind of that influence. You know, this person is touching a lot of other things. Now let's figure out which one is the most prestigious and which one has the most incoming. And that's actually going to highlight one of our meeting areas, and that actually has 16 connections coming into it. And if you notice, team 2 drops down to number 4 in our list, which is interesting in of itself. We can also take a look at some of our other centrality metrics here. So say we wanted to identify what is the most influential node inside of this link chart itself. We can use something like PageRank centrality to help us kind of understand that. In this case, it's interesting that the most influential is this Birkenhead car park. It's one of our NAIs, and it actually touches a lot of our individual movers, and it is just overall, according to the PageRank centrality score, it is actually the most influential. And we can go ahead and take a look at some of these neighborhoods as well. So let's go ahead and compare some neighborhoods between, let's figure out what who all our 2 meeting areas have in common. So as you can see, our 2 meeting areas right here have team 3 and team 2 were present in both of these meeting areas, which is interesting. Now, if we switch this back and just look at the individual neighborhoods, we can see that this one is tied to team 2 and team 3, and this meeting area is tied to team 3, team 2, kayak, and team 1 as well. So yet again, whenever we bounce back to compare neighborhoods, yet again kind of show that the only 2 that they have in common are team 2 and team 3. So like I was saying, this is just some of the analysis that you can do inside the link chart, and it's really designed to help you understand and iterate through different questions that you might have and understand how your data is connected, and really helps you bring out those individual pieces of information that were not readily apparent just by visual inspection alone. So with that, thank you, and I'll turn it back over to Natalie.
Okay, guys, thank you. That was a great rundown. I'm going to ask now for Commander Ebel to come on live with his webcam and his audio, and for Natalie and James too to come back. Let's give that a minute for that to happen and make sure everybody's connected. Okay, thank you guys. Commander Ebel, welcome. Thanks for joining us today. We've got about 5 questions for you, and if you could just entertain them and educate us all. So let's just start off at a real high level. Just tell us a little bit about yourself and your role at Green Bay Police.
Yeah, thanks, Carl. I've been with the Green Bay Police Department for 33 years. I currently oversee the investigative division, a team of about 35 individuals from forensic staff, the crime analysts, to our school resource officers and investigators. My other duties that I perform is large-scale special event planning. So Packer games, concerts at the games, and any type of large-scale event, 4th of July, stuff like that.
Great, thank you. And then before we get into some of the link analysis questions, can you provide us just a little insight into some uses of GIS at the Green Bay Police, and then maybe even how over the years you even first became aware of GIS technology?
Yeah, so I was introduced to the GIS platform back in 2013 when I became a district captain, and I wanted to map our crime data in my district and also the social disorder type crimes in my district so that we can address some of those with our community police officers and our patrol officers. Our IT director is a GIS specialist, and him and I developed a very strong working relationship as we were mapping out the crimes in my district. I moved on to the operations division commander, and I used that ArcGIS to watch all of the districts that I was responsible for then, along with the social disorder and the crimes and stuff. Since then, when Esri came out with ArcGIS Tracker, I was one of the first people to raise up my hand and say, I want to use that, and I want to use it for Lambeau Field. So what we did with the tracker is we built out a dashboard with your help, and we deployed Tracker to all of our officers at Lambeau Field to show them spatially within the building and within the campus of Lambeau Field where they were at. And we have a lot of great success with that. Be able to pinpoint our officers when they call out for calls for service, or if we're sending somebody to a suspicious package, when our EOD canines, we can send the closest one. So we also use Tracker for our tactical mapping. We use the Esri platform for SWAT callouts, and also loading in blueprints for all of our public schools and a lot of our local businesses. We now have all of their blueprints within our system, and we share that with fire and our SWAT team and officers.
Great. Natalie, I think I'm going to turn it over to you now for a question or two.
Yeah, I had a question. So you got started with ArcGIS because you wanted to visualize things on a map and do spatial analysis on those things. But what led you to start moving into using ArcGIS for link analysis, and how is that helping with investigations?
Oh, link analysis, you have a database, a records management system, and all of that data gets entered into it. And sometimes it'll just sit there. Well, we have about 2 million records in our system, or a little bit more. And I want to be able to use that to make those connections that are there that people don't see, our investigators don't see, our patrol officers don't see. And it's something that allows us to be able to uncover those hidden connections and give us investigative leads. Instead of just sitting at a computer and digging through a records management system, this is something that can run the process and display it for the investigator in front of their in front of them. They don't have to spend hours digging through it.
Yeah, that's great.
You know, and
Yeah,
James
quite
even
powerful.
brought it up. James even brought it up in his demonstration. The geographic connections within a link analysis map can also put, you know, the people that are involved in the crimes, whether it's a burglary ring or a retail theft ring, they can put them geographically close to each other to make those connections when you're doing your analysis.
Great. James, you have a question?
I do, yes. So for your current efforts with link analysis, can you tell us some of your data sources and kind of like what it took to actually access data from your data records management system, and really kind of what it takes for like an initiative like this to take root in a police agencies such as yours?
So, you know, we're unique in Green Bay that we started building our own records management system back in 2007. We just recently signed a 15-year contract with all of the other police agencies in our county. So we have all of law enforcement all dumps everything into the same database. Being that we have our own records management system, we have programmers on staff, that's all their job is. So the data sources that we get is from our record system. But more importantly, I can go up to our second floor where our programmers are located and ask them very nicely, of course, to give us a view into the database that we can then plug into Pro Intelligence. And it really is great for us. And I know other agencies that are on are going to have a hard time getting the vendors to give them that data unless you have some type of link into your database. You need a champion. In a project like this, I'm looking at doing our whole entire database, but you need a champion that has that vision and that can try to institutionalize that vision that they have, so that when they move on, either retire, like hopefully I will someday, or if they move on to another division, that vision doesn't leave with them. So you have to be able to institutionalize what you're doing.
And then Natalie, I think we have time for one final question for the commander.
Yeah, so I just wanted to ask, like, so what's next? I mean, obviously, you know, you guys are currently using Pro Intel to help with investigations, but like, where do you want to go next? Where do you see this evolving? Just kind of, you know, pick your brain on that.
Sure. You know, all the agencies across the country are seeing a big rise in gun crime. We saw a 200% increase last year in our gun crime, which drove us to acquire a NIBIN machine, which is the Integrated Ballistic Information Network through ATF. And we're getting ready to go online with NIBIN, which will then connect to Chicago, Milwaukee, and the National Center through ATF. My plan is to be able to map those shots fired, the shell casings that we find in neighborhoods to other shootings that are related, that we just don't know, that we don't have that connection right now because we don't have the system in place or technology in place to be able to see it. With NIBIN, we'll be able to do that, and then with link analysis, we'll be able to put that in geographically into our map in the entire county, because we will be a regional site for the NIBIN machines. And then we're also working on mapping some of our active warrants for our patrol officers, so that they can drive around and see where they're in the neighborhood, and a department dashboard similar to what we have for our Packer games that we use.
Well, linking crime guns and spatially visualizing those, Paul, is a great use case. We'd love to have you back and report out on the progress, you know, in the coming months. So I'd thank you very much for joining us for this roundtable. We'll let you get back to your day in Green Bay, and I'll ask Natalie and James to stay on, and we will follow up with some final questions that the audience has asked during this last 45 minutes. And I think thank you, Paul.
Thanks, Paul.
Natalie, I think the first one's going to be for you. And is this a tool just for GIS analysts? And I'm going to expand on that a little bit because we get this question a lot. And why don't you just add why and who did you build Pro Intel for?
Sure. So, ArcGIS obviously is a professional GIS, and we have lots of different applications that help you use your GIS data, especially if you're a GIS analyst. But what we've also found over the years is that there are Intel professionals that need they need location, right? Like you can know the who and the what, but if you don't know the where, you're going to have a real hard time supporting operations appropriately and giving the necessary information to go and action on that intelligence. And so we built ArcGIS Pro Intelligence to learn from since 1969, all that institutional knowledge on how to handle location information, and then added to that to pull out the other facets of your data, like temporal analysis and do link analysis and look at the relationships within your data holistically in one view. So all the tools and capabilities that are in Pro Intel are built for intelligence professionals across many different industries.
Perfect,
Well,
thank
that answers
you.
your question.
Yeah, that's awesome. Next question, is there a limit on data size? For example, a cap on the number of nodes or relationships?
So there's not a hard cap, but there is one thing to kind of keep in mind about that is it kind of goes into the density of the graph or the density of the link chart itself. So the more nodes and the more entities and the more relationships that you will have in there, it will adversely impact it if you get into the tens of thousands and you have a lot of relationships being drawn. Because you got to think, like in a table, if you have a table with a couple 100,000 records and it's drawing everything back and forth, it's going through, it's iterating through that, and it's trying to draw all those relationships, and it will impact that performance. So there's not a hard and fast number as far as entities and relationships, but it's kind of a sliding scale based upon how dense your link chart actually is. So.
Okay, thank you, James. Next question, is it necessary for the data to be visualized on a map to be included in the link chart? For example, if you import a list of individuals with no location data, can they be included in the link chart?
They can be included in the link chart. So you can use a standalone table and bring in, so if you just had a list of names and there's no location information associated with that list, that's totally fine. You can create an entity type from that. The one thing to remember is that you do have to have an OID, which is an object ID, in order to bring that in. So Excel, if you bring in an Excel spreadsheet and add that to your contents, you'll be able to bring that directly into a link chart. If it's a CSV, which doesn't have an OID, you'll need to first add that to a geodatabase. That OID will be added and you can bring it in.
All right, perfect. Next question, can you represent dotted line relationships between individuals and entities, I'm sorry.
Yes, so you can. And you can do that based on, you can set and apply symbology to both entity types and relationship types, and you can apply that to the entirety of the relationship types. So if you wanted to have a specific type of relationship, i.e., going back to some of our examples, like the work score, you wanted to have it solid line gray or dark black or something along those lines. But then some of the other ones that were derived from like spatiotemporal collocation, because that's less firm, if you will. You could apply those as a different color dotted lines or anything else like that. And you could take that and you could do it that way. That's definitely possible, but it has to be applied to the entirety of the entity set or the entity type or the entirety of the relationship type. So.
Okay, perfect. We have a few more questions that are either a little more complicated that we probably need to respond to via email, and we are also running to the top of the hour. If we can go now to our closing slides. First off, thanks everybody for joining us. You'll see here, this was the third session of a three-part series. If you want to see the video recordings of all these sessions, the URL is here. It's also posted in the chat. If you enjoyed today's session, we hope you did. There's also a survey at the end where you can answer a couple quick questions for us that will make us hopefully perform and conduct these webinars in a better way, if need be. And then just pay very close attention. We have very strict parameters on how we reconnect with you. If you have questions about mission, about licensing, about software, and you want us to reach out, you have to indicate so on that survey, and we'll get somebody right back in touch with you. And that closes things out for today's session, folks. I hope you enjoyed today's session as well as the other two that we did, and we will see you next time.
See y'all.